Okay, Assalamualaikum and salam sejahtera. So today we're going to discuss about continuity test. Okay, continuity test by using the multimeter, and we are going to try it as in our three-phase MCB, in magnetic contactor, and also in our overload relay. Okay, so continuity test is very important to make sure that your connection in motor control circuit is okay, and it is not put otherwise in bad manner, okay, or maybe we short each other. Okay, so in our multimeter you can see here, okay, as in here, where the we can see the sound symbol here. Okay, if I try to touch both probe, you can hear the sound. Okay, you can hear the beep sound. Okay, you can hear the beep sound here. Okay, if there is no connection, no beep sound. Elsewhere, you can also use, if there is no symbol, sound symbol like this, you can use also the ohmmeter, okay, to check the ohm, where you can put the selector, and then if I try to put this, you can see some values on the multimeter. Okay, you can see some values on it. Okay, if there is no connection, then it will be number 1. Okay, now we try to this is our three-phase MCB. Okay, our three-phase MCB, and let's say this is in switch on. Okay, and you can hear the beep sound in we change the selector to sound, and we can hear the beep sound. Okay, which means this is this side and this side is connected. If I try to switch off, and then there is no beep sound here. Okay, that's a simple continuity test for our MCB. So basically we check between MCB and to the other side of connection. Let's say we have the three-phase MCB, then we'll go to the single-phase MCB, then we check the connection between the three-phase MCB and the single-phase MCB. So we know that we really tighten the screw here, where some of students, they make mistake because they are not properly tighten the screw here, so that the cable will loose. Okay, now our second component is magnetic contactor. Okay, so we finish our MCB and we go to the magnetic contactor. As for our magnetic contactor, okay, this is our magnetic contactor. Okay, maybe I will try to explain it again. Where this is okay, you can see here, it is A1 and A2 here. A1 and A2 here. Okay, A1 and A2 is the coil for the magnetic contactor, and the others is the contact. Okay, you can see here, this one, this set are used for three phase. Okay, L1, L2, and L3. Okay, this is one. This is used for three phase, and the contact on the side. Okay, we use that is as we use it as our contact for control circuit. Okay, you can see the numbering here. It is normally open and normally closed, 13, 14, 21, and 22. Okay, so we know that 13 and 14 is normally open. So if you check using the multimeter, in normal condition, there is no connection between number 13 and 14. But our number 21 and 22 is normally closed. So if you check here, you can hear the beep sound. Okay, what happen if the coil is energized? A1 and A2 energized. Okay, we can simulate it by pressing this button. Okay, so which means when A1 and A2 energized, there is no connection between 21 and 22. Okay, we try it for our this is our normally open. Okay, normally open. When we press it, there will be beep sound. Okay, there will be beep sound for our normally open. We can hear the beep sound. Okay, okay, and then when we release it, there is no beep sound. Okay, so this is our magnetic contactor. Okay, repeat again. This is A1 and A2. A1 and A2 is our coil. A1 and A2 our coil, and on the side we have two normally open and two normally closed, and this side we use as for the three-phase supply for power circuit. Okay, the last one as for today is our overload relay. Okay, as for our overload relay, this is our overload relay. Okay, normally we check it as in our connection. If you go back to our circuit, okay, if you go back to our circuit, we can see that our overload relay is over here. Okay, number 95, 96, 97 and 98. Okay, as in our connection, 95 and 96 will go through the circuit, will supply the circuit to our control circuit. Okay, but 97 will go to the trip. Okay, so now we try to use continuity test to check with how this overload relay works. Okay, if you try to check here, this is number this is 98, 97, 95 and 96. Okay, so in normal condition, you can see normal condition, this is the reset button. We try to press the reset button and you can see a small white lash here comes out. Okay, you can check here, there is no connection in 98 and 97, but there is connection between 95 and 96. But if I try to test it to, let's say our overload relay is tripped, okay, it will become like this. Okay, then the connection now, there is no connection between 95 and 96, but the connection goes to 98 and 97. Okay, if I press the reset button, then it will go back to 95 and 96. That is the principle in our magnetic our overload relay. Okay, so that when we go through back our circuit, you have to understand that during normal operation, the connection is between 95 and 96, and the supply will go through here, and our circuit, our control circuit is okay. But in condition of trip, where overload relay is triggered and the trip it will trip the circuit, the connection is no more between 95 and 96, but now it goes to 95 to 97, and it will cause our trip button to switch on. Okay, so I think that's all for now. Okay, thank you very much.